All right, this is my explanation. I did not do this on my own, so I do not get credit. But basically, I'm going to try to explain it as fast as I can, but most efficiently. If there's any questions, put them in the comments. Here we go. So we're trying to figure out the time that it takes from when you first get in the second photo gate to when you leave, that time in between. So some things that we know that acceleration is constant, so we know that that's going to stay the same throughout the whole problem. We know that it starts from rest, so that's going to mean that the initial velocity is 0. And I drew a diagram of the ramp here, and a couple more things that we do know is that photo gate number 1 is triggered at 160 centimeters. So that's 20 centimeters from our starting, because he dropped it at 180. He also taught us that. So that's 20 centimeters there. And then we also know that photo gate number 2 is triggered when the front is at 90. So that's 90 seconds from that 180. Cool. So we also figured out from the demonstration that any time through the average time through photo gate number 1 is this 0.1597 seconds. So what we can do is we know that the time that it took for it to reach the back of the photo gate minus the time that it took to reach the front of the photo gate is going to equal that time in between. Because if you go the bigger one to the back minus the front one, it's going to end us with the time in between. So that's what we found. Cool. So how is that going to help us? Well, we can use that information and use the kinematic equation number 3. So we know that the initial velocity is 0, so you can just plug that in there. That gets rid of it. We're left with x equals 1/2 at squared. So what is x? Well, x is our displacement, and we know that it took 20 centimeters to get to the first 160, and then it'll take another 10 centimeters before it reaches the end, because that's how long the flag is. Cool. So that's the front of the car, that's the back of the car. Well, we can just use those and plug it into this equation. So we'd have 20 equals 1/2 a times t front squared, because it took 20 centimeters to get to the front. And that's the same with this. 30 equals 1/2 a times t back squared. It took 30 centimeters to get to the back. So when you solve that out, we'll get these two both equal to a. Well, we know a is a constant, so we can just plug them together. So that'll be this. What you can do is you can just cross multiply and then just use algebra, which will leave us with this final thing. Time of the back equals square root 3/2 time of the front. Well, using this equation, we know t of the back now, so we can just plug in our new t of the back right in. So that's what we do here. So now we have root 3/2 tf minus tf equals our previously found 0.1597. And then a really important thing is that we're going to factor out the TF. So obviously it's multiplied by root 3/2 here and -1 here. So just take out that TF, and that way we can have this chunk together, so it's really easy to get the TF by itself. So we can do that, divide it out, and we'll get this seconds. So what we can do in order now to find acceleration is we can go back to this previously found equation and just plug in our TF, which is this new number. So you plug that right in for 40/TF squared, and that'll get you an acceleration of about 79 centimeters per second squared. Now, how is that going to help us? Well, now that we know acceleration, we can use that same equation again, and what we can do is that we know that this total time, or this total displacement here is going to be 90 centimeters plus another 10 centimeters. So it'll be 90 centimeters and 100 centimeters of displacement. Well, we have pretty much everything we need to solve for t. So we can go ahead and just do that. Now I know Ahmed did solve his online too, and he had 120 and 130 for his displacements, which I don't really understand. So if that is right, and I'm completely wrong, that's totally fine. I'm pretty sure we have the same thing up until that. So just keep that in mind, because this could be wrong. But I believe it's 90, because 180 minus 90 is 90. 180 minus 80 is 100. So that's what I think. So we're just literally plugging in all the stuff that we know. V initial equals 0, our acceleration, the 90, and solving for t. So then we finally have two t values, because we solved for the t of the front of the second gate, the t of the back of the second gate. Well, we can just take t of the back minus the t of the front, and that'll get us, like before, the t of right in the middle. Round it to 4 decimal places, and we're done.